hopefully it'll soon.
Shh. At Hershey Park in Hershey, Pennsylvania, there is a roller coaster that's called the SooperDooperLooper. This was the first looping roller coaster on the East Coast. Constructed in 1977, this roller coaster has exactly one 57-foot vertical loop. Now, this is normally the part of the video where I try to transition to something that helps us better understand a topic in circuits, but today's topic only has its name in common with my anecdote. Talking about the SooperDooperLooper means that yes, today we get to talk about superloops. A superloop arises in the situation where I have a current source between two independent loops when I want to do mesh analysis. A superloop is akin to a supernode, but more like a doppelganger than a twin. The superloop has its own superpowers, kind of like the bizarro versions of the supernode. 1. The current source places constraints on currents. And 2. A supernode follows KVL, so we can write the KVL expressions around the big loop that we get by taking out that current source but leaving the name of the loop currents the same. Now this is probably nonsense, so let's do an example to understand this better. Here we're going to find the loop currents. Step 1 is to assign loop currents. Note that a superloop is created because there's a current source between two loops. Step 2 is to apply KVL and Ohm's law. We start with the constraint. We will write this by putting the current source on one side and realizing that the other side should be plus the current going in the same direction as the source and minus the current going in the opposite direction. This is going to yield negative I1 plus I2 equals to 2. Then we write KVL around the big loop created by removing the current source. Going clockwise, we get negative 5 plus 1I1 plus 4I2 equals to 0. Simplified, this is I1 plus 4I2 equals to 5. Step 3 is to solve. Our A matrix will be minus 1, 1 on the first row and 1, 4 on the second row. The X vector is I1, I2, and their multiplication yields the B vector, which is 2, 5. Plugging this into MATLAB, we get that I1 is negative 0.6 amps and I2 is 1.4 amps. So hopefully you'll be able to see that this is pretty similar to mesh analysis, but we get two equations from our superloop. SooperDooperLooper. SooperDooperLooper. That's really fun to say. Thanks for watching. If you've enjoyed this video, I would love it if you would subscribe. You can find me on Twitter or Instagram at BD McPheron. This is Dr. McPheron. SooperDooperLooper.